Okay, you write down this mass spring damper system, and based on this you write down this equation. That equation you write down mx double dot plus ch dot plus x equal to f of t. You write down the equation mx double dot plus ch dot plus kx equal to f of t. Below this you write down where mx double dot is equal to mx double dot is equal to inertia force into the system. Inertia force below this you write down ch dot is equal to damping force. Below this you write down k into x equal to spring force. बघा लक्षात आलं का mx double dot is equal to inertia force which is produced into the system. Second you write ch dot, that is the damping force. The damping coefficient is here, that is the c, and which is the damping force produces as the ch dot. And third one is the spring force kx, that is the spring force kx will be produces into the system. And last one f of t is the external force. Okay, so इकडे बघा already we know the each and every system having there is an equal and opposite reaction. So in this system whatever the initial forces are produces that are equal to the external forces. Which are those initial forces? All these forces are initial forces, and which is external force? That f of t is the external force. So that equation of motion which is produces as whatever the forces are internal forces is equal to the external forces. And what are the internal forces? With respect to the mass, with respect to the damper, and with respect to the stiffness k. And based on this, whatever the addition of these internal forces with respect to the inertia force, damping force, and spring force is equal to the external force, that is the f of t. Okay, so you based on this you write that derivation, that equation of motion which is general equation of motion which is produced as a mx double dot plus ch dot plus kx equal to f of t. बघा या ठिकाणी महत्त्वाचं म्हणजे काय, that m which is changes with respect to the acceleration, that m which is changes with respect to the acceleration. Second thing is that the damping force c. What is the damping force? That damping coefficient is c, and which is changes with respect to the velocity, that is the first derivative, that is the x dot, that is the x चे डेरिव्हेटिव्ह पहिलं म्हणजे काय असणार आहे velocity, x चे डबल डेरिव्हेटिव्ह म्हणजे काय असतं आपलं acceleration. X is nothing but a displacement. What is mean by the x? That is x is nothing but a displacement. X dot म्हणजे काय असतं आपलं velocity, that is the derivative of x with respect to t. And if we take the double derivative of x, that will become as a acceleration. All of you understand? X is nothing but a displacement. If we take the first derivative of x, it will become a velocity, that is the dx by dt. And if we take this double derivative, that will become a acceleration, that is the d2x by dt square. That will be a acceleration, that will be a double derivative with respect to t of x. Okay, so based on this inertia force, damping force, and spring force produced into the system, that all the forces are internal forces, and that f of t value, that is the external force, is applied to the system. And based on this, that m coefficient is related with the inertia force, so that m is proportional with changes with respect to x double dot, that is m into a that is M into X double dot, that is mx double dot, that is the inertia force is produces into the system. Second thing is that C value, that C is the damping coefficient, and in this C damping coefficient, that C is the damping coefficient and which it changes with respect to the velocity, so that C into X dot, that will be a C changes with respect to the Cx dot, where K it changes with respect to X, so that Cx dot, Kx and Mx double dot. In this way, there are the three forces produces into the system, and which are those? First one is the inertia force, second one is the damping force, third one is the spring force, and whatever the external force applied to the system, that is the F of T. And already we know there are the inertia force, there whatever the internal forces that are equal to the external forces, and based on this there is a balancing this equation, whatever the initial forces are equal to the external forces, and the equation is produces that mx double dot plus cx dot plus kx equal to the F of T. And you write down this, and below this you write down this is the general equation of dynamic analysis. So write down these points. Okay, if you are completed, we'll go for the next point. I hope all of you completed. So below this write down, we go for the next derivation. First derivation, that will be based on the free vibration of undamped system. So write down free vibration of undamped system. Okay, write down this name. First we draw the diagram. You draw this diagram. This is a free body diagram of this. You write down the name as a free vibration of undamped system. Free vibration of undamped system. Below this, you draw this diagram where K, M, and X. M is the mass of the system. K is the spring constant K. And if you go for the free body diagram of this, what will happen? That K is proportionate with respect to the X. That's why that spring constant, spring force will be produced as a K into X, and M that will be produces that mass of the system with respect to the inertia force X double dot, that is the M X double dot. All of you understand? प्रत्येक वेळेला तुम्ही लक्षात ठेवत चला. बेसिक आयडिया काय आहे? M changes with respect to M झालं की X double dot will become. लक्षात ठेवायची इन होल चॅप्टर, सगळ्या चॅप्टर मध्ये जेवढे काय डेरिव्हेशन्स आहेत, in all the derivation you should know that M that will be proportional with respect to the acceleration, that will become a mx double dot. Second thing is that K असेल तर K is proportional with respect to the velocity, so that will become as a K into X. And you come towards the third point, that is the C. C is the damping coefficient which will be changes with respect to the velocity, so that Cx dot. तिन्ही पॅरामीटर लक्षात ठेवलं की आपल्याला कुठेही चुकत नाही. फर्स्ट वन इज द inertia force with respect to mass m, so that it will be proportional with respect to the acceleration. Second thing is that will be k into x. K म्हणजे काय? Stiffness. K is the spring constant K, and force कुठला प्रोड्यूस होते? Spring force. That K is proportional with respect to the x. And third one is the C. C into x dot. C म्हणजे काय? It is a damper coefficient, and it will be changes with respect to the or proportional with respect to the velocity, so that this will be a produces with respect to Cx dot term. That term will be Cx dot Kx and the Mx double dot. The Mx double dot का काय म्हणतो आपण? Already we have seen inertia force. Kx का काय म्हणतो आपण? Spring force. And Cx dot का काय म्हणतो आपण? Damping force. हे तिन्ही term you have to be keep in your mind. Okay? At all time, that three parameters. Why? Which are those? M is proportional with respect to acceleration. K is with respect to X, that is the spring force. C, that is the damper with respect to the velocity. These three parameters you have to take into the account. Okay? लक्षात घ्या. या प्रत्येक वेळेला ह्या तिन्ही टर्म असणार आहेत. That is the inertia. Second one is the inertia force. Second one is the spring force, and third one is the damping force. Okay? So based on this, if we go for the first equation, that is the free vibration of undamped system. What is this? Free vibration of undamped system. तर त्यामध्ये बघा free vibration आपण बघितलं already we have seen. What are those? First one is the types of vibration. Which are those? First one is the free vibration and forced vibration. त्याचा डिफरन्स कसा बघायचा आपल्याला? तर या ठिकाणी कुठली व्हॅल्यू असते? f of t. तर फ्री व्हायब्रेशन म्हणजे काय? that f of t will be equal to 0. तर आपलं जे इक्वेशन आहे बेसिक इक्वेशन which is the what is the equation? कुठला आहे आपलं इक्वेशन? बेसिक इक्वेशन. तर आपलं बेसिक इक्वेशन आहे ते कुठला आहे? that is mx double dot plus cx plus mx double dot plus cx dot plus kx equal to f of t, where बघा that this is a general dynamic equation for the analysis. From that mx double dot म्हणजे काय? that is the inertia force which is produced into the system. Cx dot म्हणजे काय? damping force which is produced into the system, and kx म्हणजे काय? spring force which is produced into the system. That are the inertia forces equal to the external force, that is the f of t. But from this system, that mx double dot is the inertia force, cx dot is the damping force, kx is the spring force, is equal to f of t is the external force. That all these are the external forces equal to the internal forces. But from this, if we go for the equation, for the different equation, which is first is the free vibration of undamped system. Equation कुठला आहे आपला? Free vibration of undamped system. But whatever the parameters that are, this is the basic equation. But based on the free vibration, based on the forced vibration, based on the damping, and based on the undamping, हे जे चार वर्ड आहेत कुठले कुठले? First one is the damping, second one is the undamping, जे 4 कॉन्सेप्ट आहेत that based on these 4 concept that equation will be going to be changed for every derivation. Okay, तर बघा आपल्याला आता पहिलं जे आहे कुठलं आपलं फ्री व्हायब्रेशन. तर फ्री व्हायब्रेशन म्हणजे काय, यामधला जो काही f of t व्हॅल्यू आहे ती f of t व्हॅल्यू काय झाली आपली 0. का, तर that value that is the vibration is a free vibration, so that for free vibration external force that is the f of t will be equal to 0. Second thing is that the derivation name is a free vibration of undamped system. Undamped म्हणजे काय, डॅम्पिंग जर असेल तर c ला काहीतरी व्हॅल्यू आहे, अनडॅम्पिंग असेल तर काय असणार आहे c is equal to 0. म्हणजे या ठिकाणी जो येणारा दुसरा जो फोर्स आहे तो कुठला आपला ch डॉट, हा जो ch डॉट आहे that is the damping force, again it will be equal to the 0. आणि या जर सिस्टम मध्ये बघितलं, if we go for this free body diagram, there is a whatever this k value is equal to minus of mx double dot, and based on this is the kind of ठीक आहे. For this free body diagram, if we go for this free body diagram, आपल्याला काय होणार या ठिकाणी that kx is equal to kx is equal to minus of mx double dot, and so that the equation will be produced as mx double dot plus kx equal to 0, and that is the equation number 1. बघा समजते का, या जर बेसिक इक्वेशन मध्ये जर बघितलं तुम्ही, that is the general dynamic equation of analysis with respect to mx double dot plus h dot plus kx equal to f of t. So for term as a free vibration, that f of t will be equal to 0. For term of undamped system, that undamped is nothing but c is equal to 0, so that total term will become a 0. So remaining parameters कुठले राहिले, mx double dot plus kx equal to 0. All of you understand? Pranali, Rohini?
Yes, ma'am.
Okay, so you write down this. We'll go for the solution of this equation. Write down this basic equation of dynamic analysis. Based on this, you go for this diagram which I have drawn on the board. Free body diagram you draw, and based on this you write the equation. Okay, so below this all of you write down, this is a solution of the equilibrium equation of motion. This is the solution of equilibrium equation of motion. Equilibrium equation of motion. Okay, and how to solve this equation by the mathematically? तर मग आपल्याला कसं सॉल्व करायचं? This is one of the equilibrium equation where mx double dot plus kx equal to 0. You write this is the equation number 1. बघा, this is a equation that is the linear differential equation, that is the mx double dot plus kx equal to 0. Then how to solve this equation? By putting x of t is equal to a into e raised to st. Okay, how to solve this equation? बघा आपण जे M3 होता आपल्याला त्या मॅथमॅटिक्सच्या M3 मध्ये जो आपल्याला M3 मध्ये जो फर्स्ट चॅप्टर होता मे बी, तर त्या फर्स्ट चॅप्टर मध्ये आपल्याला कुठला चॅप्टर होता, नाव काय त्याचं, लिनियर डिफरन्शियल इक्वेशन. तर लिनियर डिफरन्शियल इक्वेशन मध्ये if such a types of the examples are over there, so we can go for this solving the equation by such a putting that x of t will be equal to a into e raised to st. By putting this x of t is equal to a into e raised to st, where तर बघा यामध्ये that a is one of the constant and s is the constant. By getting these two values, whatever this constant, which are those constant, a is the constant and s is the constant. या दोन्हीच्या जर व्हॅल्यू आपल्याला मिळाल्या तर we can get a solution of this differential equation. Okay, so बघा, this is one of the equation, equilibrium equation, and for solving this equation if we go for this x of t is equal to a into e raised to st. तर लक्षात आलं का बघा, तर या ठिकाणी x which is changes with respect to t and x is equal to a into e raised to t, that is the value. यामध्ये बघा आता आपली इक्वेशन काय म्हणते, which is this equation mx double dot plus kx equal to 0, but that k value, x value is here and that is the mx x double dot value. So we have to take the first derivative and the second derivative of this. What is the derivative of this x? dx by dt, that will be equal to the x dot. What is the derivative? काय असणार आहे सांगा मला? a is the constant into e raised to s चे derivative काय असणार आहे? a into s into e raised to st. That is the first derivative of this, that x, that is the dx by dt, that comes under this velocity. That's why it is written as the x dot dx by dt is equal to a into s into e raised to st. If we take the second derivative, what is the second derivative? That is x double dot, that will be becomes that is x d2x by dt square, which is the double derivative of x with respect to t. Again that a is a constant, where s into s into e raised to st, that will be become as a into s square into e raised to st. बघा या ठिकाणी तुम्हाला समजते का? All of you write down this. काय असणार आहे बघा, for this equilibrium equation, solving this equilibrium equation, we have to go for putting this x of t is equal to a into e raised to st, where a is constant and s is constant. If we solve, if we calculate these two values, that is a and s, whatever the solution we will get, that solution is that equation, that solution of this difference, solution of this equation of motion. For the free vibration of undamped system. And for that, if we put this x of t will be equal to a into e raised to st, and if we calculate the first derivative, that is nothing but dx by dt is equal to a into s into e raised to st. If we take second derivative, that will be become that e to x by dt square is equal to second derivative of this, where a into s, where e raised to st is a current derivative से काढलं तर काय असणार आहे, s into e raised to st, so that it will become as a s square into e raised to st. Okay, so all of you put these two values, that is x value and x double dot value, in the equation number 1. So do this, and all of you write this in your notebook and put this value of this x dot and x double dot value in the equation number 1. Maybe all of you complete this. So put these two values in the equation number 1. काय होणार बघा इक्वेशन m into x double dot. What is x double dot? काय राहिले बघा a s square into e raised to st, that is the x double dot value, plus k into x. What is the x value? x काय होता आपला a into e raised to st bracket complete equal to 0. Okay, what is common term? Take outside the common term. काय राहिले बघा या ठिकाणी a into e raised to st into bracket काय राहिले बघा m a square plus k bracket complete equal to 0. All of you write down this. M a square plus k into common term is a into e raised to st equal to 0. Okay. So as far as our mathematical portion, a into b is equal to 0. जब a into b, a multiplied by b is equal to 0. At that time, what is the concept that a is equal to 0? Then b is not equal to 0. Already we know. A is equal to 0, then b is not equal to 0. So applying this concept here, we can put here a into e raised to st is not equal to 0, then m a square plus k equal to 0. All of you understand? When a into b is equal to 0, when a is not equal to 0, then b is equal to 0. So same we have to apply here. When a into e raised to st is not equal to 0, then remaining term b, that is m square plus k equal to 0. So put this. And what is this? M square plus k is equal to 0. So what will happen? M square is equal to m square plus k equal to 0. So काय राहिले बघा मग आता? If you have written this, I will erase this and go for the next point. बघा काय राहणार मग परत? m a square is equal to minus k. M a square is equal to minus k, so that a square will be become as a minus 1 into k by m. A square is equal to minus k by m. If you have completed, I will erase this and go for the next step. Okay. So all of you write down. That a square is equal to minus k by m, where minus 1 into k by m. Okay, a square is equal to -1 ची टर्म काय असते सांगा बरं म्हणजे मला I square is equal to -1, so that we can put here that I square into k by m, where taking the roots on both the sides बघा x चे रूट जर घेतला तर काय राहणार आहे त्या ठिकाणी k by m into I plus or minus k by m into I. So write down this plus or minus I into k by m, where you can write where root of k by m is equal to omega n, that will be equal to the natural frequency. Okay, all of you write down. बघा कसं झालं या ठिकाणी आपलं इक्वेशन होतं कुठलं ms² plus kx equal to 0. For solving this equilibrium equation, we have gone through the process. X of t is equal to a into e raised to st. If we go for this, taking the first derivative and second derivative and putting these two values into the equation number 1, directly we will got this equation as a s square is equal to minus k by m. So by putting this -1 as a I square ची value काय असते? It is a -1. So if we put this I square into k by m, if you go for this, taking the roots on both the sides, s is equal to plus or minus I into k by m, root of k by m, and that root of k by m, that is the formula. Which formula is here? That natural frequency is known as the root of k by m. So that we have put in here that s is equal to काय आहे या ठिकाणी बघा plus or minus I into omega n. बघा that s is equal to plus or minus I omega n. So all of you write down this. S is equal to plus or minus I omega n, means it will become as a s1 and s2. S1 is the plus I omega n and s2 will be as a minus I omega n. Write down this. Write down this formula on the top in your notebook. Omega n is equal to root of k by m, which is the natural frequency. Natural frequency. So already we know the basic equation. Which is our basic equation? Bagami, if you have completed, I will use this. Do it fast. I will flash this diagram. बघा हे कंप्लीट झालं असेल, मी इरेज करते आता. That was the first point of our derivation. काय आहे बघा, this is a S12 value. What are these? S1 and S2 will be equal to plus or minus I omega n. But already we know काय आपल्याला माहिती आहे सांगा that x value काय आपली x ची व्हॅल्यू आपण काय पुट केली होती? x is equal to a into e raised to st, where s is the s1 and s2. So that काय करायला लागेल आपल्याला that x of t is equal to a1 into e raised to s1t plus a2 into e raised to s2t. That is the two parameters, that two roots of the equation, which are those s1 and s2. So that x of t will become as of a1. A1 is the constant, and we have to go for this s1. S1 value काय असणार या ठिकाणी बघा, that s1 is nothing but a plus or minus I omega n, means yes, e raised to s1 is a plus I omega n plus a2 into e raised to minus I omega n. So write down this. Okay, all of you read on this? S1 and S2 value, that are the plus or minus I omega n, and from that A1 into e raised to S1t plus A2 into e raised to S2t, where S1 is the plus I omega n, S2 is the minus I omega n. So put these two values here, and based on this already we know the formula. What are these formula? E raised to plus or minus I alpha. What is the formula? काय formula आपला सांगा? Cos omega काय असणार या ठिकाणी बघा? E raised to plus or minus I alpha. What is the formula? That is the cos alpha plus or minus I sin alpha. Already we know that e raised to plus or minus I alpha. What is the formula? Cos alpha plus or minus I sin alpha. Put this formula in above equation for the e raised to I omega n